morning. I am Asha from the Department of Mechanical Engineering, Global Academy of Technology. Today I will be discussing on projection of hexagonal lamina beta angle problem. Problem goes like this. A hexagonal lamina having edges 25 mm is placed on one of its corners on HP such that the diagonal passing through the corners on which the lamina rests is inclined at 45° to HP and 30° to VP. Draw the top and front views of the lamina. So the given data in the problem is it is of hexagonal lamina having side or edge equal to 25 mm and it is placed on one of its corners on HP. So if it is placed on HP, then first position should be below the XY line and it is resting on one of its corners. So one of the corners should be at the extreme left position. The diagonal passing through the corner on which the laminar rests is inclined at 45° to HP and 30° to VP. So it says that the first position is in HP, second will be inclination with respect to HP, that is 45°, and third position will be inclination with respect to VP, that is 30°. And it says the diagonal passing makes an angle of 45° to HP and 30° to VP. Whenever the word diagonal, perpendicular, bisector and median comes into picture, it is a beta angle problem. So construction of hexagon, take 25 mm or measure 25 mm in your compass and draw a circle with one of its extreme left point. Start cutting an arc equal to 25 mm radius and cut 5 times and join these arcs. Then you will construct a hexagon. So let's look into the top view. The top view appears as a hexagonal because it is placed in HP and it is resting on one of its corner. So it is resting on the corner A. Resting on HP on one of its corner, the first position will look like this. The top view will be a hexagon and front view will be a straight line. So when I am viewing from the bottom, I will be able to see A, B, C, D, whereas E and F will be hidden. Whichever is hidden, I am writing within the brackets. So I have constructed a hexagonal lamina of edge equal to 25 mm and it is resting on one of its corner. The corner point is A and name it as A, B, C, D, E and F. My line in order to get the front view. I am able to see A, B, C and D. E and F will be hidden. So write in the front view A dash, B dash in bracket F dash, C dash in bracket E dash because E is hidden and D dash. So from A dash to D dash it should be of visible line thickness. Now the second is the diagonal is inclined to HP at 45°. Keep your protractor at a convenient distance and draw an inclination line to 45°. It should be of projection line thickness. Now in compass measure the distance from A dash to D dash. With A dash on the XY line, cut an arc on the inclination line. Now again measure A dash to C dash. From your compass, measure the distance A dash to C dash with A dash on the XY line. Cut an arc. Then you will get the point C dash in E and E dash. Again, measure the distance from A dash to B dash. Transfer the same measurement on the inclined line. Now make this A dash to D dash as the visible line and you trim the extra lines. So from A dash to D dash, that diagonal is inclined to HP at 45 degree. Now project all the points onto top view. Name the front view as A dash. Since you have transferred the same line onto 45-degree inclination, whatever the naming you have written, same order you have to write it down. A dash, B dash, C dash, D dash, E dash will be within bracket and F dash should be within the brackets. Okay, now project the top view and connect A dash with A. This is point A, B, C, D, E, F. Connect using visible line. So this is the construction of the hexagon when it is tilted to 45-degree inclination. Name it as A, B, C, D, E and F. Project A dash intersection point will be A. Like that you name for all the remaining points. So show the inclination, that is 45 degree. Now third is inclination with respect to VP 30 degree. Keep your protractor at a convenient distance. Draw the angle. Measure, since it is a beta angle, true length first you have to consider. True length of the diagonal, that is A to D. Mark it anywhere on the inclination line. You should make sure that your hexagon should never cross the XY line. So you have to measure the original diagonal A to D, mark anywhere on the XY line. And draw the locus. Okay, now measure the distance from A to D, that is the diagonal of the hexagon from the second position, and with the same A as the center, cut an arc on the locus line. Now connect the points and measure the beta angle. Beta angle should be around 44 degrees. Name it as AD. This is the original D from the first position. Okay, now measure the distance from A to F. You want to construct the hexagon taking into consideration all the points. So measure A to F from the second position. With the A as the center, cut an arc. See, in hexagon, A to F and A to B will be having the same distance. Same way D to E and D to C. So you can see from this, that is A to B is same as A to F and it is same as D to C and D to E since it is a hexagon. So cut from A to B and A to F from the point A on either side. Same distance from D, cut two arcs representing C and E. Now measure the distance from D to B and D to F. Cut an arc. Similarly, from point D, cut two arcs D to B and D to F. Now using visible line, connect all the points to construct the hexagon from the third position. Now use the projection line to project onto front view. Name it as A, B, C, D, E and F. Now project all the points. D dash with D, that is the intersection of D dash, C dash to C, B dash to B. Project everything onto get the hexagon of the final view. Now project everything. F dash to F, that is the point F dash. Now use the visible line A to B, B to C, C to D, D to E, and E to F. Now name it as A dash, B dash, C dash, D dash, and E dash, F dash. Measure the beta angle. Beta angle is around 44 degrees.